let's look at another very interesting concept called as stationarity. Stationarity is like a key assumption in many modeling approaches, especially in classical time series modeling approach. There are various algorithms to test the stationarity of a time series, but in simple terms, stationarity means the data distribution of a time series, or maybe we call a time series stationary when the probability distribution or the data distribution remains the same at every point in time. In simple words, if you pick different windows in time, the data distribution across all those windows should be same. For example, let's look at this example. We have something like this. Now, if you pick this horizon, calculate the mean of this, mean 1, mean 2, it should be very similar. So in this case, we can call this time series stationary, and mean is just one factor of it. We can also look at variance over time. So you need to understand two simple terms. First is mean over time, and second is variance over time. So as we know, a standard Gaussian distribution is defined by two parameters, the mean and the standard deviation. So these two assumptions are required for a time series to be stationary, that the mean should not change over time, the variance should not change over time. Now let's look at an example of non-stationary time series. So let's say we have a time series like this. Now in this case, if you pick two different time horizons, one is this block and the other is this block, you can clearly see that the mean of this block is less than this block. Hence, there is a change of mean over time, and hence we can consider this time series as non-stationary. Another way a non-stationary time series would look like is in the form of seasonal change. Now, how the mean changes over time, and that leads to whether the time series is stationary or not. Now, let's look at change in variance over time. So, let's take an example of the second case. So, we have, let's say, time series. So, in this case, if you look at it, in this case, the variance starts low and then it keeps on increasing over time. It keeps on getting bigger and bigger. Hence, we consider this as non-stationary series. So now we know what is stationary and non-stationary time series. There are various algorithms that we will look into in the upcoming tutorials. There are various statistical methods to check for it. Now, before we move ahead, let's understand the predictability of a forecast. And there are some assumptions that we need to have. And the most basic assumption when we forecast a time series is that the future depends on the past. In statistical terms, we call this behavior as autoregressive. So a time series is autoregressive in nature. That means the future depends on the past values. But not all time series are equally predictable. So for example, let's say sales of a product. This is in general a good forecast. We can create a decent enough forecast for a sales of a product. But let's take another example where we have like stock prices. Most of us will think that, if we know about forecasting, we could predict the stock prices and then make a lot of money. But it is not true because forecasting stocks are not easy. Most stocks have a pattern that we call as random walk, and this is something that we will again dive into the upcoming tutorials. So there's like a random behavior of it, and there are too many factors involved in a stock forecast that we are not aware of. There are, you must have heard people have like multiple strategies for trading. They perform the fundamental analysis, they perform the technical analysis, and in general, the fact is that share prices are not really a function of their past values, but actually an anticipation of their future values. And this kind of violates the basic assumption, right? So let's come to our main concept, which is predictability. And that has like three main factors. First is DGP, or data generating process. It's very crucial to understand the data generating process so that you can come up with various strategies to handle the forecast. If you understand the data generating process, you will know how to fill in those missing values, you will know how to handle the anomalies, you will know how to perform feature engineering or create features which would help in your forecast. So understanding business, understanding data generating process is very crucial. Second is the amount of data. So it's really important that you have sufficient amount of data. And generally people have a thumb rule that you should have at least two cycles of the data as your training data. Let's say you have sales of a product at a daily level. You have recorded it at a daily level. So you'll have multiple seasonalities to it. You'll have weekly seasonality, you will have monthly seasonality, you will have yearly seasonality. You will have multiple trends in it. So you should have at least like 2 years of your sales data to have a better forecast for the upcoming months, like let's say for 3 months or 6 months or maybe a year ahead. And third is that your data should have adequate amount of repeating patterns. So for any statistical model to work, there should be like a repeating pattern in your time series. The more repeating pattern you have, the better it is to forecast. Because as we have discussed, time series is autoregressive in nature, which means the future depends on the past values. So let's say you have data like this, and suddenly due to some reason, you have a data like this. So in this case, you cannot use your past values to predict future because your past doesn't represent your future, and that is where forecasting becomes very difficult. As we discussed, you need to have the data generating process, you need to understand it, you should have sufficient amount of data, and your data should have sufficient amount of pattern in it. There are various statistical terms again to measure the predictability of a time series, which we will dive into later. Later on, we will understand what is a white noise, what is a random walk, and what to do in such cases. How to know if your data has sufficient amount of pattern or if your time series data is predictable enough or not, whether it is a white noise or not. So let's catch up in the further sessions. Thank you.